Hello everyone, my name is Adam Sobecki and I'm a student at the University of Warsaw, the Faculty of Mathematics, Informatics and Mechanics. At the same time, I'm a member of Warsaw Team, consisting of the 5 of us, my mates. I'm going to tell you some information about the student cluster competitions I have taken part in and to talk to you today. So let's get started. Warsaw Team is a team consisting of undergraduate students preparing for the student cluster competitions. We have already taken part in the 2 of them. The team was created when we received an email about an opportunity to join the ASC 17 team under the supervision of the Interdisciplinary Center for Mathematical and Computational Modeling at the University of Warsaw, called ICM. We were the first team from Poland qualified to the ASC. It all started that way. There are 3 major student cluster competitions. The first one during the United States-based Supercomputing Conference, ASC. The second one during the International Supercomputing Conference, ISC. And the third one is ASC Students Supercomputing Challenge. I guess that most of you are interested in what student cluster competitions are, so let me explain to you what it is all about. In brief, we build our own clusters, that is the cluster part, for a live face-off to see whose cluster is the fastest. There is also a competition part. In this part we are given real scientific workloads to run and a power limit of 3000 watts we cannot exceed. The winning team is the one with the highest performing system. Depending on which competition it is, our goal is to obtain the shortest time of the execution on a specific workload or to run as many workloads as possible during the competition. What we can do is, first, to optimize the source code of a specific application to be more efficient and parallel. And the second thing is to find the best parameters of the parallel execution on a cluster we built ourselves. A very important thing is also to choose the proper software which can get us a better performance. Sometimes there is also a deep learning task in which we need to create and to train a model and achieve the best result on a specific dataset.
Hi, I'm Marcin Mielniczuk. I went to ASC 17 and SC 17. I'm going to tell you about the former. I chose Magnum Wave as my task of choice. Why? It had the most to do with programming. And it took a lot of learning to live up to the task. First of all, I needed to learn Fortran. And that's the language they haven't ever touched beforehand. Many historical reasons, some features meant for HPC, but definitely worth knowing. And the second thing was that the application, which has won the Gordon Bell Prize a couple of years ago, was meant to run on Sunway Taihulite, or how the Chinese prefer to call it, Shenway. And that's a completely different architecture. It's heterogeneous, but not in the meaning of CPU, GPU. It has nodes with master cores, and each master core has 64 slave cores, a completely different paradigm. The Chinese have built their own compilers, their own assembly language, even their own parallelism libraries, documented in Chinese. So it was hard. They had their own OpenACC. They had an OpenACC dialect and something pthreads inspired. It was really challenging, but also very rewarding. What we achieved? There were 230 teams for the preliminary. 20 of them got qualified to the finals. We were among them. We were the first Polish team to ever qualify. Then, during the finals in Wuxi, we won the 2nd prize in the HPL benchmark and achieved the 6th place overall. The competition was really hard, and it took very long preparations. 2 months until the preliminary deadline, 1 more month for preparing for the finals, and then 5 days of tough work during the finals. The final tasks were not easy, and I would like to share some highlights. For example, during the for Falcon, our system administrators needed to come up with the whole queue system, because otherwise the application wouldn't just run in parallel. For in lamps, the workload triggered a segmentation fault. So it was, if we wanted to achieve a really good result, we need to hunt down the bug and get rid of it, which we did. It was a lot of there was a lot of joy in our booth. There was a lot of enthusiasm. It was great to go there. China isn't like anything you can meet in you can see in Europe or in the United States, and it's a completely different culture, completely different cuisine. And our team has integrated a great deal, much more than during the whole preparations. I'm really happy that I had the opportunity to go there.
Good morning, my name is Dominik Psujek, and I'm one of the team members responsible for hardware and software setup of the cluster, both during the preparations as well as the competitions. I joined the team in August 2017 during preparations to ASC 17 Denver. The tasks included preparing the hardware, installing the software, and running tests on various configurations. For example, different versions of compilers, MPI toolkits, and libraries like AIM, KL, and CUDA. Then, during the competition, I made sure everything was prepared for the other team members to perform their computations and fulfill the given tasks. We had to deal with a lot of interesting problems like servers dropped during the transport, bad RAM sticks, bugs in accelerators firmware, or rogue attempts to break into our servers. Regardless of the problems, we managed to fix all the issues and get competitive results in almost every task we were given. The conference also gave us a chance to meet some incredible people and show that the world of HPC is really easy to get into, but on the same moment really challenging. Right now, our preparations for ASC 18 include meetings and progress reports on applications. Those are answer prediction search query using CNTK deep learning framework and rely on for reconstruction of 3D models of biological particles from images taken by using state-of-the-art cryo-electron microscopy.
Now we are preparing for the ASC 18 in May and ISC 18 in June. We are also planning to expand the team with a few new members and continue to take part in the next competitions. We have a great support from the ICM, and we are going to take an opportunity to broaden our knowledge, develop some new skills, and learn more about the world of high-performance computing from people like you from such conferences. We want to thank our sponsors. During ASC 17, Inspur provided us with their servers, NVIDIA lent us their GPUs, Tesla P100s, and Alinea granted us a license to their software. During SCC 17 in Denver, Boston IT, Cool IT Systems, NVIDIA, Mellanox, and MuseFS equipped us with the hardware and software, which was essential for our start in the competition. Thank you for coming and for giving us the opportunity to share our experience with you. Thank you very much.